Now it's time to catch up with answers on some of the comments. And I was just browsing my old videos, and I've seen a couple of comments that YouTube has not shown to me. So sometimes if you comment on videos and I don't answer, it's not because I'm rude to you, but because I just do not see the comments. Now I have 100 plus videos, and often when there's a comment, especially in older videos, it just doesn't show up on the notifications. And of course, I just cannot go about testing hundreds of videos and loading each of these to check for comments. So probably if you are commenting on an older video, then it will take a very long time until there is an answer to the comment. And these were comments on this video on natural versus mechanical sound. And let me just try to scroll it down. And Arnold had a fantastic comment on compression drivers. I will look into that later. Now I will tackle Jacob's question on the impedance of the drivers. So he would like to hear some more detail on the subject. So he said that it is important to understand what kind of effect impedance has on sound quality, but I don't really have a grasp on how it does it. So let's just talk about a little bit about that. So the sound quality that you get from your amplifier and speaker combination is really a negotiation between your amp and between your speakers. And of course we can include your room on that, the room acoustics and your source. We could get really complex on the issue, but the most important bit where impedance has its role is this negotiation between amplifier and driver, and their impedance is key. And it also means, when we look at the easiest form of it, like when he asks here that there's a 4-ohm version and 8-ohm version of the same driver, why would I choose one or the other to make a loudspeaker? And it is because of this negotiation process. They behave very different. So you have several considerations to think about when you want to choose 4 or 8-ohm driver. One of your consideration is what kind of amplifier you are using. If you are using an amplifier that's built to put out large current, then you would go with the 4-ohm version. And such cases are modern Class D amps and most of the solid state amplifiers. There are some which are built to handle higher loads, like 8-ohm, 16-ohm loads. For example, if you look at the Michael Yee amplifiers, they are solid state, but they work absolutely wonderful with high impedance drivers. I would say you get better sound quality with them, with the Michael Yee, than using the low impedance versions, but that's an exception. Those amps were designed to handle that. Most solid state amps, especially which are made today, they aim at dumping as much current as possible, and they will be happier if they see a lower impedance driver. So 4 ohm is kind of the Goldilocks zone for most of the solid state amps today. If you if you go lower than that, let's say 2 ohms, then the demands on the amplifier become extremely hard and harsh. However, if your amp was built to handle it, then it will be happy to do so. But most amplifiers are not happy enough to handle 2 ohm loads. And so that's why you need like a Dan D'Agostino or something like that to to work with super low impedance loads. However, vacuum tubes, they want to see as high load as possible, and that's because the vacuum tubes produce very high voltage as an output, and they need a transformer to transform it down to low voltage. If you so when you look at a vacuum tube amplifier, you will see that they have output taps. So if you have a 4 ohm speaker or an 8 ohm speaker, you would hook them up differently. So you hook up the 4 ohm speaker to the 4 ohm tap, 8 ohm speaker to the 8 ohm tap. If your tube amp doesn't have output taps, it doesn't mean that you can hook up any ohms to it. It still means that it has a specific ohm output impedance that it would like to prefer to see. And you do not get a choice to optimize the negotiation process between your amp and your speakers. You are just given one choice. Sometimes they tell you what it is or what it isn't, and usually what they do is the amplifier topology uses error correction to be able to handle the other loads, but it will be a compromise compared to having different output taps. And when you have the proper 8 ohm tap, it means that the output transformer will transform the output voltage, which is super high, not to a tiny one that corresponds to a 4 ohm signal, but to almost 50%, like a 42% larger signal that corresponds to an 8 ohm load signal. And so it means that the difference between the original signal and the one that the output transformer gives you, the ratio between them is smaller, and there are less modifications, less distortions introduced to your signal. So your amp will be much happier driving a higher load if it's a tube amp, provided you have the correct output transformer. I know this sounds a little bit complex, and I don't know if it helps understanding, but unfortunately a lot of things in audio are just super complex, and that's why there's no easy fix. There's no easy product. There's no best product, because there's so many parameters to consider that it's not just a mix and match situation. You really, when you have a loudspeaker of a specific impedance or a driver of a specific impedance, essentially your consideration is to make it work with the amplifier you are using it with. And a big mistake that the commercial amps do, but actually it's not a mistake, it's a huge necessity, is that they want to make loudspeakers to work with all kinds of amps, and they want to make amplifiers to work with all sorts of loudspeakers, but this is pure BS, because the impedance requirements make your loudspeaker super specific, so they can handle only a little pool of amplifiers as optimal drivers for them. So basically, after this long response, my short response is you choose your drivers so that they match your amplifier best as possible. And let's see the second part. What if you use 2 8 ohm drivers and 1 4 ohm driver in a 3-way design? Is that a thing? Yes, you can do that. However, that was the short answer, but there's a super long answer on how to do it. And I would say that if you want to get into loudspeaker design, I really recommend to first start out with single driver designs where there's no crossover involved, and then you learn about the process of how a loudspeaker communicates directly with an amplifier, what an amp does to the sound directly. And even if you don't like the sound, you will have a tremendous experience basis. Because first, if you want to become a good loudspeaker designer, I mean a great loudspeaker designer, if you want to become good, just read the textbooks, get it done with, and use a CAD program, and you will learn from your mistakes and get slowly better. But if all of us, all of you loudspeaker designers out there who want to go that way, this is not enough, and that's not the way. If you want to have a company that has lasting products, and not just products in quotes, but a loudspeaker that is special, that talks to people, translates music, you have to first understand how how a loudspeaker, how a driver interfaces with your room acoustics, how your ears perceive the sound of a driver. And when you become familiar with it, then you can split it in two and use two drivers and use a basic crossover with it. And now here comes the response to your question, is that first just try drivers which are of the same impedance. So for example, look at your amplifier, see what output impedance it has, what are the taps on it, like 4 ohm taps, 8 ohm taps. I would say when you are starting out, it's safer from the design process to use the 8 ohm driver, provided your amp has 8 ohm taps. Because even though, let's say you have a solid state amp and it has both 8 ohm and 4 ohm taps, but you design a 4 ohm driver, 4 ohm speaker, but you don't know how well your amp can handle dips down to below 4 ohms. So then your choice can become trickier, and if you use drivers that dip well below 4 ohms, let's say down to 2 ohms, then you will have very unsatisfactory bass response from those speakers. And also, if you choose to go to lower impedance, it also means you will need much better speaker cables. So it pretty much means you have to double up your speaker cables to have them sound the same way compared to an 8 ohm load. So that's one consideration, is as you go lower in impedance, then you will need to get much more expensive, much better loudspeaker cables just to keep at the same level of performance as if you were using an 8 ohm driver. So if you want to do some loudspeaker design, first single driver speakers, then very simple crossover with a simple two-way design, and after you have had about I would say like a decade of experience with these, only then I would recommend so that you tackle a three-way design, because making crossovers for three-way designs is a task for master speaker builders, and we are, with our material that I have shared with you, we are really far away from that level yet. We are about 5 years or 10 years too early for me to share that information with you, because if I share that and you don't know the basics yet, I will set you up for failure, and we don't want that. So anyway, this response is getting really long, and it seems that I'm off topic, I'm dancing around, but I am not. Because I believe that all of your questions, they really point to the fact of how you choose your drivers. So this is about how to design speakers, how to make your own speakers, how to choose your speakers. And what I told you are all parts of it. And what I'm telling you is not the bare bones recipe what you hear on the internet, that it just get parroted out. People are repeating it like just the old mantras that they read somewhere or heard from somewhere. This is something that you would hear from people who are masters of loudspeaker design building. So anything that you do in audio, especially speaker building, it requires to have a really wide experience base. And the problem today, what I see, is that people want to tackle loudspeaker building strictly from the electrical point. And it's, if you just understand that part of how to match the impedances, that's not enough by a long shot to make a good design. First, you need to understand, why do I want to mix and match such different impedances? And there's just so many considerations on how you choose your drivers. And if you choose drivers that way, like 8 ohm plus 8 ohm plus the 4 ohm driver, I would say that's a 99% failure mode to build a loudspeaker. There are some loudspeaker driver combinations that will work really well that way, but if you just set out with the purpose of building such a loudspeaker, you are setting yourself up for almost automatic failure. You have to approach impedance from a very different point. You have to understand how the loudspeaker characteristics truly work. What is the frequency range where a loudspeaker is comfy working? How you can mate it with others in a balanced way. And to do that, first we all need to understand what a single driver does to the sound, and then we can start parsing it out. And at this point, I would also like to mention that if you go this way, you might just get just stop at the beginning. But have a look at it at the next video. So I hope, Jacob, I've answered your question to a certain degree. I could have been much more concise and just answered with a few sentences, but then it would have seemed that I give you specific knowledge, but I would have just set you up in the wrong direction, and it seems you would have learned more, but you would have learned nothing, because I would have given you information that's completely useless at the level you are looking at the problem. So I hope it helped. If not, just share your comments, and thank you for watching my videos. I really appreciate your honest comments, and these are the kind of comments I would love to see in my videos. So thank you. Bye bye.